if we're ready, my name is Yuri, and I hope you like puns because I'm going to take you on a Swift journey. So, a little bit about myself. I see this thing isn't working. Now it's working. So, just so you know the context about myself and don't think I'm just a crazy guy on stage talking about things that I don't know, I've been a mobile developer for over a decade already. So I did both Android and iOS, and lately I've been focused more on the iOS side. I played a lot with cross-platform things, even geeky stuff like C++ put inside Android and iOS with OpenGL, Genie, Dropbox's cross-platform solution in C++, so a lot of geeky stuff, I like to call them. I like to call myself a tech enthusiast. I like tinkering with things, especially hardware. One of the things I built, and I'm proud of it, that I built myself an electric skateboard that I actually ride and it doesn't kill me. It didn't kill me yet. And I'm people-oriented, and that's what I'm focused on lately. So by people-oriented, I mean I'm focused on growing new developers, on channeling their energy into something, and trying to get the best out of them. And this thing should start working, and now it does. So now, to get to the fun stuff, a little summary of my presentation. So probably you got it by the name. It's going to be mostly about Swift. I'm going to talk a bit about interesting things about the Swift language, about iOS, about Xcode, and I'm going to try to find tips and tricks that you can apply in your own environments, in your own teams, on your own projects and languages. And one of the things, which might sound a bit weird, that's up there on my screen, is to apply this knowledge onto onboarding new people. Hang in there, I'll show you why I put it there. So one of the things that I didn't coin the term, but I like to call it that, the defensive coding style. Let me tell you a bit about it. So my whole focus on this started many years ago when somebody showed me a simple C++ hack to access private variables and modify them. I'm not going to go too much into detail. Maybe some of you have heard about it, but I'm going to go through it a bit. So we just see some basic hello world here, a class that has a private variable, we echo a name, pretty simple stuff. Now let me show you this. So with some clever things, a little bit of pointers and stuff like that, we can access that variable, we can modify it, and what do you think it outputs? It outputs hello Yuri, which is very convenient for me. And this is the thing that started to make me think in this direction of defensive programming. And let me show you another thing that Apple did about this. So for those who are not iOS developers, I'm going to quickly tell you about closures. It's something we're very used to on iOS, very similar to Lambda functions on Java, basically anonymous functions. And the only thing you need to know for this presentation is that we have two types, escaping and non-escaping. Basically, translating to layman's terms, escaping closures are used for asynchronous work and non-escaping for synchronous. Most of the time, we developers use asynchronous code because we have a lot of API calls and whatnot. So most of our closures are escaping. But Apple created these two annotations, escaping and not escaping. Why do you think Apple makes us mark the closures escaping if they are escaping? Because we use them all the time. Why not just let them have nothing and just mark the non-escaping closures? That is because Apple, in their thinking, wanted you as a developer to consciously make the choice to make an escaping closure because it occupies more memory, it's harder to produce, and that is in the same mindset of the defensive coding style. So for this slide, I had many variations, but when I was practicing, a colleague of mine overheard it and liked this variant, and I left it here. So I like to associate this as to a socket cover. So we try to protect the people who don't know what they're doing, to protect them to not do bad things, and we want to inconvenience the people who know what they're doing as least as possible. Again, that is not perfect. You will need to adapt that to your own teams, to your own environments, but the idea is there. One advantage that we'll be using of Swift today to show this is the fact that it is statically typed. It's one of the many languages that is statically typed. I won't go too much into this. It's just like Kotlin, Java, C, C++, sometimes you can declare variables, sometimes they can be inferred, but all of this can be used to our advantage to make mistakes as less as possible and to make people misuse your code as least as possible. So, one of the many things that we on mobile have to struggle with is all the things related to code, that is strings, localizations, images, UI, fonts, and maybe you have the same things in your environments. Some platforms like Android do a little bit better deal of strings, for example, but on iOS it is a big problem. And one of the transformations that we'll be doing is we'll be compiling these things into something statically typed, so we can check for errors at the compile time. And I'll show you how. So one of the tools I've discovered and applied on my project is Stencil. It is a Swift pattern generator. There are many pattern generators for any other languages that you might want to use. And basically, with a script wrapper around it, you can generate whatever you want. And there is a very nice utility that I discovered called SwiftGen, which makes life even easier because it has already some functions built in. All we need to do is build some YAML files that help us compile things in the right manner. So in this example, I'll be talking about strings. Basically, localizations. In iOS, it is a nightmare. Localizations are binary files that always show conflicts in source control, that are hard to read, and if you have a missing key, you might not see it until you run the app, which we don't want. So we'll use Swift's enum powers to circumvent that. And here on the right, we can see a simple example of a YAML file that we feed to SwiftGen that will generate some strings based on a string file that we'll see in the next slide. On the top, we could see just the two basic strings that I included in the project. And below is some code automatically generated by SwiftGen that will let us use enums to use those strings. And if we go to the next slide, we can see that it takes me one line of code to apply that into the app. And if my string ever goes missing, I could run SwiftGen at compile time. I'll see that that string is missing, and no crashes at runtime will happen, which is a good thing, I say. Another thing in the same key of generating things is Xcode Gen. So some of you might have that in your projects. We on iOS have that problem. There is a master project file, which contains a lot of settings, different attributes, includes different dependencies, libraries, etc. And what we found in the team is that it's a good idea not to commit that file to source control. It would be very nice to rebuild it every time. One of the tools that helps us do that is Xcode Gen. So the same way SwiftGen works, you have a YAML file, which is the master configuration file for that project. Here we have just a simple one with a name, a bundle prefix, an iOS version, and that's it. But you can also include other dependencies, your own dependencies, Swift Package Manager dependencies, any specific build settings, architectures, whatever you want. And again, I see this as being applicable to many other platforms, not just iOS. And with this, you don't commit your project file to source control, as I said. You run this every time you check out a branch, and your project is built. And we'll see that on the next slide. So yeah, here we see the project built after a quick run in the terminal. And the one downside to this is that I want you to be aware of is you might see this as a problem if you work in a very big team. If you check out branches, like the master branch a lot, and it changes a lot, new files are added, you might have to rebuild the project file every time you check it out. But I think that's a good trade-off for the safety that we commit an actually readable file to source control instead of whatever Xcode provides us. So now, about another pain point in mobile development, especially on iOS. So we have this xib and storyboard files, which are UI files for iOS. I think you might have seen them on other platforms. If I'm correct, .NET has the same drag and drop way of building UI in some scenarios. On iOS, that has been the default way until recently, until Swift UI has appeared. But still, many projects in production use the old way. We need to maintain them. And I'm going to tell you a good way to make it more flexible and make it more maintainable. So what I'm going to show you is how we get rid of xibs and storyboards. We replace them with UI in code. We will do the same exact things that storyboards do in UIKit code. If you would not be comfortable with UIKit code, you could use a library like Snapkit for iOS, which is a nice wrapper around what we'll do, but I would still recommend you use pure UIKit. And you probably can find the same kind of alternatives for other languages. One more thing that is a very nice bonus, we will be using the SwiftUI preview for UIKit. What that means, I'll show you in a bit. So here's just a small snippet of code that shows you how we can set up a view in code. Basically, we instantiate the elements. Here you see a basic label, a basic button, some code to set the colors, and a very interesting property being set called translates auto-resizing mask into constraints. That means we take over the layouting of the view in code. And on the next slide, we can see the magic happen. So for the label, we can see its X anchor being set, its Y anchor being set. The same for the button, an X anchor, a bottom anchor. Basically, you would anchor that view to any part of the screen, just like you would do in a storyboard. But now it's in Swift code. Now it's in source control, easily readable. Now any developer can look at it and understand it easily when he looks at a pull request. And now about the SwiftUI preview. This presentation is a little bit late because at WWDC there was a preview presented for UIKit, but nonetheless, maybe this would be interesting for you. So one of the things we always wanted on native mobile development is hot reload, instant preview, things that React Native, for example, had for a long time. Flutter came with it and is doing it great. We on mobile had always problems with this. And with the migration towards SwiftUI on iOS, that became possible. But how about old legacy code in UIKit? So there is a nice way to circumvent that. And I'll show you how. Basically, for those who are iOS developers, this little snippet of code does the magic of wrapping old UIKit element, in the situation of view controller, into a SwiftUI element. And that makes it possible to use in the SwiftUI preview. And we can see that here. And now, by inserting this little snippet of code anywhere we want to preview our view controller and writing our UI in code, any modification is instantly visible. You don't need to reload the app. You don't need to compile it every time. It's one of just those nice things that make your life easier. Another mindset that I really want you to think about is forcing failure and embracing failure. I'm guessing many of you saw function methods that have an empty return. Well, I am kind of the advocate against that, because I think every method should have some kind of feedback, and you shouldn't fail silently. I'm actually a fan of failing as much as possible in development, so you don't have to do that in production. Don't commit bad code after this presentation so it fails in production. That's not what embracing failure is about. One of the things that helps us do it is the result class in Swift, and there's a bunch of equivalents in any other languages of the result type. So what is the result type? It's basically a wrapper type that has two cases for success and for failure. And what does that do? That makes you as a developer understand what you're doing better treat all the cases. And if you don't, it's instantly visible by others that you missed a case or you didn't treat a case. It's much more visible than it would be otherwise. Again, in the same key, use asserts as much as possible in development because they don't affect production, fail as much as possible in development, and try to write as many scripts that could prevent things from compiling if they have something that shouldn't be there. That usually means you should have a good DevOps in the team, or you should be a smart developer, which most of you, I think, are. So a little bit more into this. You should use your IDE to the full potential. What you see on the screen are some hidden features of Xcode. Apple never marketed them and never published them in their documentation. But they're readily available on the internet, they're talked about, and I encourage all my colleagues to use them, and I now encourage you to do that. What do they do different than comments? In my opinion, they are more visible, they're integrated into the IDE, they show up clearly, and when somebody sees that bandage or that flag, it's definitely a bigger question mark than just a comment. I suppose this kind of things are available in many other IDEs, and I encourage you to try it out and see if that fits for you. One more thing that we have in Xcode, and I like using, and this could be applied in other places as well, is some pragmas for warning and errors. So you could generate a warning with a comment, you could generate an error, and I'll leave it up to you to find good use cases for that, but just so you know, there are tools to do that, if you ever asked yourself the question. And the last thing that I want to talk about in this defensive programming style is using data types where possible. I don't know if you guys can see that array of integers on top. I've stumbled many times upon this kind of code. I couldn't understand what's going on, and we'll dive a bit deeper into it in a bit. Also, the example below, you can see a few tuples, which is just a pair of items being returned, and the difference of using a label where possible and not using a label, which makes all the difference in the world. So now, returning to my example of using data types. Let's dissect what I showed earlier. So it was an array of integers. It could have been anything. And one of the aspects that I liked in domain-driven development and took it into my daily coding life is naming. Here I didn't do anything else than just give some type aliases to the data. But now when somebody stumbles upon this code, he understands, at least superficially, what's going on. So you have a graph segment, you have a graph value. All things that a human can comprehend. An array of integers isn't that. And now we can improve it even a little bit more. We wrote some code, we wrote some structures. We tried to wrap it up nicely, and if you look at the final line, you could see that the difference between that and the first thing I showed you is minimal. But it's much more readable, and a programmer can trace it back. Now, as I said, the changes on that line are minimal. And that takes me back to my analogy with the socket covers, that we, again, should protect those who don't know what they're doing, and we should inconvenience those who know as least as possible. Here, you have just a dot in it extra added to that line. So not a big inconvenience for developers. And that's about it for my presentation. I hope you liked it, and I hope to see you at our Vortex stand. Maybe play some Guitar Hero. You have some records to break. We set some today. And yeah, thanks, guys. Now to the Q&A, I guess.
Thank you. I'm going to have to rely almost entirely on you because I'm not a Swift developer, so I'm not going to be able to jump into that. I will try, I will do my best. I'm not going to let our speaker down without any questions, but hopefully, you being more closer to this type of development, you have some questions for him. Okay, I think I still have to take a shot. One of the things, I mean, not necessarily a question, but more of a kind of outside remark, if you want. Over the years, I've been doing all sorts of mobile development. You know, back in the day when we had Palm OS, Windows Mobile, Symbian, and other, let's say, weird technologies. And back then, it was almost all the time using technologies that we were already using for other stuff, right? So almost all the time, the development environments were already familiar. Now, for Apple, they are really close. And while I'm happily using their products, I know that while the products are great, they're amazing, the development experience is not always good. So you mentioned, like, every other sentence, you were mentioning that other IDEs already have that, other platforms already have that. So just a curiosity, how hard is for a Swift developer, for a developer working in the Apple ecosystem, to actually keep up with everything that is being done in the other sides of the world, in the other technologies?
So actually, back in the day, it was much worse. So that is a good thing. That's already an improvement. Back in the day when we had to write Objective-C, which was a derivative of C++, written in a special way by Apple, it was a lot harder. But now, with Swift, what Apple did and is doing is quite great, because they're adapting the language specifically to their platforms. They're making it as easy as possible, so the barrier to entry is lower, because before, to be an iOS developer, it was pretty hard. You needed to have the hardware, which is still a requirement right now, but the language was a lot harder than any other mainstream language. Now they're opening up things. They open sourced Swift, so you can compile Swift code on Linux. You can't write iOS apps yet on Linux, but who knows? Maybe that is coming. What I would like them to improve, really, is the IDE. I feel like it's their weakest point. It's a really crash-happy IDE, which would have a lot to learn from Android Studio.
Hasn't anyone yet come up with maybe an extension or plugin for VS Code to bring some of that, flexibility that we have in the other technologies to bring into the?
So
Apple
there are a
developers?
lot of things that depended on Xcode before. IntelliJ had an IDE that was geared specifically towards iOS development, but you could not open storyboards and zip files, so the UI files inside that editor. You would still have to rely on Xcode. But it was a really nice IDE back then. Now that we're switching to declarative UI with Swift UI, where all the UI is written in code, I feel like we have a big opportunity to find a new IDE and adopt it, and maybe it will make our lives easier. But still, Xcode has some nice features that are well integrated with Apple's ecosystem. For example, when you connect a new device, it automatically signs it. All the development things you need are already prepared and are there. But yeah, there are things that I would improve.
Excellent. Okay, let's see if our audience has some questions.
Yeah, so I would have a question. Great talk, by the way. As a disclaimer, I'm not an iOS developer, not even an Android one. If I need to do anything mobile, I would go probably with Capacitor or maybe Flutter. But going back, so you said something that with the previous, the old way of working with UIs, UIKit, if I remember right, you had a way of doing drag and drop.
Yeah.
Now, I see the benefit of going to something fully declarative with Swift UI.
Yeah.
But is it like over regarding the visual editor, the drag and drop stuff, or is there also an alternative with Swift UI to do something like that?
It's over. It's over? It's the end of that.
And then my actual question would be, maybe I'm missing something, but what's the value of actually cutting something that could give a chance to some designer to someone maybe not fully technical to do some UI work?
Yeah, so when it initially came out, it was a very nice thing. So storyboards, the main UI kind of canvas for iOS, was a very nice thing when it came out because you could have multiple screens, you could have the connections between the screens. So just as you said, somebody not that technical could set it up, could make it look like he wanted, and it was fine in theory. But there were some missteps that eventually led to the downfall of storyboards to the extent that already for like 5 years, people don't use storyboards but use XIBs. XIBs are individual screens packaged in one file, and the storyboard is just a collection of more screens. That is because, one, their underlying structure is unreadable to the human eye. It's just some gibberish with XML. And it's very conflict prone. So the UI editor in Xcode starts inserting a lot of things when you just open the file. Once you start working with a bigger team and you have 2, 3 developers on iOS, that becomes a problem really quickly. So that's why people are ditching it.
Okay, so they had to cut it, had to let it go. Okay, thank you very much, Yuri. Let's see, we have time for one more question if anybody has one. Okay, no? Thank you very much for your time. Thank you for the presentation. And we are going to head up into our next session.